My name is Tooba. I recently did my bachelor's in computer science, and currently I'm working as a data scientist at Data Science Dojo. And besides working, I like to travel and I'm a big foodie. So let's get on with the talk. So you must be wondering that why I chose the topic of interactive data visualization with Python, right? So I cannot answer in this question in one line. So I think we will need to go through the entire presentation to figure out that why I chose this topic. So I have split the entire presentation in 3 parts. So firstly, we will talking about data, then we will covering the part of visualization, and then we will add the interactivity part to the visualization later on in the presentation. So what is the importance of data? Why data literacy is so important, right? So you might already know that there are 2 types of data, right? Something that is human readable and something that can only be read and interpreted by machine. So the goal is to make the data, to transform the data that is only readable and interpreted by machines so that humans can also understand that, right? Because we also want to see the information that the data can communicate, right? And in our childhood, everybody, I think, used to prefer books which mostly contained images over text. So why is that? What is the reason that we always love images so much? So as a matter of fact, as you can see on the screen, when people hear information, they are likely to remember only 10% of that information 3 days later, right? However, if a relevant image is paired with the same information, people retain 65% of the information 3 days later. So this is the reason that why everyone always prefer images over text. Now, one of the most efficient ways to use data is in the part of storytelling, right? Now, you can use different ways to communicate your data in the form of a story. So the first way is to maybe reflect your data using a sentence, right? And that will be the case when you have very limited data. The second way is to just maybe display the data points which you have collected or which you might have gathered from somewhere else, right? And the third part is the visualization part, right? You can use the same data and convert or transform into a figure or image which is more expressive, right? And why do people prefer that, or why do we want to do that? We'll discover that later on. Another important thing is that when you're building a story, you need to add context to your data, right? So when you display an image, it is not self-explanatory unless it has all the context to support it, right? And that is where context comes in. The other thing is that you need to use your data strategically. Making a plot or an image is not as easy or as simple as you think unless you plot it wisely, right? Because you want to communicate the maximum amount of information in the most simplest way. And if you use your data wisely, only then your data is the hero. Otherwise, it's not, because you will not be using the data in its full potential. So the first thing you can do by using the data is to show the trends in the data, right? The hidden trends which cannot be seen in the raw data points, right? You can compare and contrast the data using different plots, using different images, using comparison plots. And the third one is, for instance, you might have some assumptions about the data, something you might have suspected while maybe collecting the data, right? But you cannot support that unless you have evidence. So that is the advantage of visualizations. You can use visualizations to support your assumptions and hypotheses about data. So let's take a look at an example. So over here I have so can everybody see the slides at the back? Okay. So I have taken the suicides data. So what this data is about. So this data is telling us the information regarding the number of suicides country-wise and continent-wise as well. And we can also see that we have GDP over here as well, right? So basically for each country, I have GDP and the number of suicides as well. And I want to analyze data, right? I want to see that which countries have greater suicides which continents have greater suicides, because at the end, this data is very useful for me, right? I might want to use the data in further analysis, right? I want to conduct some research, or maybe I have some specific questions which I want to answer. Okay. So let's look at this first plot over here. What this plot is trying to tell me, that it is trying to show me that if there is any relationship between the GDP per capita for suicides per 100K of population, and this data is specifically for year 2009, right? So I wanted to figure out that if there is some trend, right? If there is some relationship between people who suicide and the GDP of that continent, right? So I made this scatter plot. Now the color might be pretty, right? But you can see circles on the screen, and what is the maximum information you can get out from this plot? You can just see that, okay, there might be difference between the GDP of different continents, right? But you cannot see any information besides that. It is a very basic plot. So this plot has its own limitations, right? So what I can do, I can add, if I want to communicate a different depth of information, I will need to add more information. I will need to add more interactivity to the plot. So, well, this plot seems a little better, right? So you can see that the size of the bubbles is different, and it is very intuitive that the size of the smaller bubble represents that for this the suicide rate was less and the GDP per capita was low, right? And for the larger bubbles, the GDP per capita was greater for that continent, and the suicide rate was higher. Another feature which I've added is that, for instance, if I want to see the exact value for that particular continent, the exact value of the suicide, I can just hover over this plot and it will display to me the continent name, the exact suicide value, and the GDP per capita. It is very easy, right? Because in the previous plot, I would have to navigate between the x-axis and the y-axis, and that would have been tedious because it would have been hard to navigate, right? And while we were navigating, we wouldn't even remember half of the information. But in this plot, I have added more information to the same plot, and it's much more easier to understand, right? And for instance, if I want to compare the suicide rates of Oceania and Europe, right? So I can maybe zoom in the plot. And you can see that I'm not distracted by any other continents, right? So this plot, in addition to the interactivity, I can also customize my plot with different continents, right? Or whatever category you have. Okay, so you might have noticed that I can see two bubbles of same color, right? So did anyone wonder why? I'm sure you did, right? So what I was trying to do was, I was trying to categorize the plotting data by the gender variable, right? Because I wanted to compare that what is the ratio, or what is the difference between the suicide rates of males and females over different continents, right? And this plot cannot show me that information because this plot doesn't have that kind of interactivity, right? So this plot is, even though it is better than the previous plot, it has its own limitations. It can only communicate a limited amount of information. So let's see that maybe if we can add interactivity to this plot. Okay, so over here, we can see that if we check out the legend side, then we can differentiate between the males and females, right? So the females are represented by the circles, and I can clearly see that there is a huge difference between the suicide rates of males and females, right? So males are generally likely to suicide as compared to females. And if I see specifically continent-wise, then I can see European males are likely to suicide more as compared to other males. So that is a very important information when you're trying to draw an analysis between the ratio of suicides, because I think eventually everybody wants to prevent suicides, right? So if somebody is trying to figure out this question, then this this point of information, which this plot is showing to me, is extremely important. Okay, so the previous plots were specifically for the year 2009, right? But I want to analyze the data of all the years. So my data is from 1985 to 2016, and I want to actually observe the change for the suicide rates of both males and females over the years, right? So I think the very basic way would be to make a plot for each one of them. But to compare them, you need to navigate a lot, and that is very inefficient, and that would be very tedious and hectic as well, right? So what I did was I basically added some time frames over here, and when I'm going to run this, you can see the change in the suicide rates for all the years of males and females, right? So in this plot, we have every possible information I wanted to have. I can see that there's a difference between the suicide rates of males and females, and Africa has the lowest suicide rates over here, and some continents, despite having a high GDP, they still have high suicide rates, right? And that is for all the years. So this is another important information which I can note from this plot. So my next question which I wanted to answer was, I wanted to compare the suicide rate between the males and females, and again I wanted to observe that trend over a period of time. So my data was from 1985 to 2016, and I was trying to see that if European males have a high suicide rate, then what might be the reason of that, right? Because we have different age groups. So it was possible that maybe 2 or 3 age groups were contributing to that suicide rate a lot more as compared to others. But these were the only assumptions and hypotheses I made while actually analyzing the data. I didn't have any kind of evidence to support it. So to make sure that I have evidence, I made this plot. And when I'm going to run this, then you can see that for the males, the age group of 75 plus has suicide rates they have very high suicide rates for all the years, right? So I can clearly deduce from this plot that this age group of males was the reason that why European males were having suicide rates overall, right? So you can also see the comparison of the other age groups, but my question was that I wanted to figure out that which age group contributed the most, and from this graph, from this bar graph, I can clearly see that the age group of 75 plus males were contributing the most. So this is another point of information which I am, which I can take from this plot. So if this was a basic plot, I wouldn't have made this conclusion, right? Because I would have to create, I think, one single plot for every year, and that would have been a lot of plots, right? If you were maybe giving a presentation or you were working within a team, it would have been quite difficult to present this data to them in the form of even 10 or 13 plots, right? So this is one efficient way to present your data, and this shows that by adding interactivity, you are actually able to present a lot of information in a very compact way, and it is also more useful and efficient as well, right? My next question was that I wanted to analyze the suicide rates in countries over all the years. So I wanted to see that what was the trend country-wise, because I had seen it continents-wise. I had compared the suicide rates between males and females. I wanted to see that which countries had the most high suicide rates, and was it decreasing over time, was it increasing over time, or there was no change at all, right? So one way to do that in Python is that you can make a choropleth plot, right? So over here you can see that the higher value of suicides is represented by a lighter color, right? So it will be a popping color, and then the darker value of the suicide rates is going to be presented by a darker color, right? So okay, so this is, right now this is the year 1985, right? And you can see that the suicide rates are spread, and if you want to see the specific country, you can just hover over the data and you can see, okay, this is Brazil and the suicide rate per 100K of population is 59.18, right? And then this is Australia and the suicide rate is 163 and so on, right? And if I would like to actually point out, if I want to point out the country with the highest suicide rate in 1985, I can just hover over this color, the lightest color, which is France, and the suicide rate over here is 348.9, right? So I can see with, I think, within 1 second, I can figure out that, okay, this is the country in the year 1985 which had the highest suicide rates. And if I want to see the overall trend, then you can see how this pattern is changing, right? Some countries were added to this plot. That means they didn't have any suicide rates before, but now they do have. And some of them disappeared. That means they were successful in eradicating suicides from their country, right? And at the end of 2016, you can see that there are very few places or areas which have suicide left, right? If you compare it with 1985, then this is a lot less. And this plot helps you to figure out that what is the trend, how the suicide rates are changing across the countries, right? Because if you want to make an analysis on a bigger level, you would need to have some plot which is displaying information at a higher level and not in a very detailed manner, which is very complex to understand. Because you want the people to understand the information. You don't want to intimidate them with the information. You want to make the information as easily and as simple as possible for them, right? So this was for the plots. Okay, so my presentation was basically inspired by Hans Rosling. So he was one of the co-founders of Gapminder, and he has this amazing TED talk on the beauty of data visualization. So you guys should definitely check it out. He basically used the Gapminder data to explain how income and lifespan emerged in the world through years. So it's a very basic, it's a very nice plot, but that talk basically makes you appreciate that how you can use Python and the Pythonic tools to actually display information in a very compact and precise manner, right? Which which anyone could understand who is able to read the plots, right? And that is all the knowledge you require. You would not need any computer science background, any mathematics background. All you need to do is read the plot, and you will be able to actually grasp the information in a very easier manner, right? So there are different libraries for interactive visualization in Python. So the first reason I did not focus on the libraries was because the reason of this talk was not to make any one particular library stand out, right? Because some of them perform the same operations, right? So it really depends on you what you would like to use. But there are some libraries that are specifically made for some specific tasks, right? And for this for this presentation, I used Seaborn and Plotly. So Plotly is used to make interactive visualizations, and the very basic plot which I used in the beginning was built using Seaborn, right? So these are the list of libraries which I chose to display it here, but you can also right? Just don't overwhelm your audience. Make sure you take them on the path of storytelling, because when you're trying to communicate information, what you're basically trying to do is you are telling them a story, right? And and everybody would want a good story who the audience can understand very easily, who they are able to communicate very easily. So make sure that you do it in very simple terms. You don't want to intimidate anyone. Your purpose is to just make sure that your point is clear and it gets across the audience, right? So thank you, and that's it for the presentation.